Okay, 8.1, interval as net change. An ant moves along the x-axis with velocity v of t equals what type of a function? Quadratic. On the interval of time 0 to 4. Okay, v of t is measured in what? Feet per second. Determine when the ant is moving right, left, and stopped. Okay, so let's graph this first. So it's a quadratic. Is it an upward parabola or a downward parabola? Upward. And how do we graph the parabola? You can find them on text. You can do it. To important points that we're dealing with when the ant is moving right or left. Sounds important, and the x-intercepts. So how do we find the x-intercepts with the quadratic? Yep, if it's a nice one, we would take the velocity and set it equal to 0. And the velocity is t squared minus 6t plus 8 equals 0. And if it's not, it should be a factor rule. T numbers are multiplied by 8. Yeah, they have to be negative because it adds to negative 6. So t minus 4, t minus 2 equals 0. So our x-intercepts are both at t equals positive 2 and positive 4 using the 0 property. Okay, so 1, 2, 3, 4. And the x-axis feet or seconds? Yeah, seconds, because we just found t, which is time. So everybody, time, there's the phone up there, in seconds. Okay, so at 2 and 4, we're crossing the x-axis. And you notice that it's upwards, so it's looking like this. Oops, I totally messed it up. My shadow's in the way, so I can't see it, or the direction I was going. Okay, top fog is really enjoying the light up there. Okay, so determine when the ant is moving right, left, and stop. This is the velocity function. What does the velocity function look like when we're going right? Positive, above the x-axis. Okay, John, when is the ant going right? On what interval? And look at this interval of time too. We're only looking at 0 to 4. Yeah, so we're only looking at 4, right? Now, question, what goes around the 0 to 2? Yep. Because at 2, we're changing from left to right. At 0, we're just going right. Okay, why do we know this? Because v of t is positive or greater than 0. And you saw when is the ant going left? Okay, so can you need an interval? Okay, what goes around the 2 and 4? Good. Because 4 is an endpoint, so we can bracket on the endpoint. Because v of t is less than 0. Equal when is the ant stopped? Good. And we know that why. Because v of t 0. Well, it's changing from negative to positive. Seconds, because v of t equals 0. Okay, displacement of the ant over the first 2 seconds. Do you remember what displacement means? What? How far it's moved since the beginning. So displacement is the position, and we remember the position function is the S function, at the end time, subtract the position at the start time, at the beginning. Find how far it's moved since the beginning. Okay? Okay, if the end time is B, and the start time is A, you subtract them, what does that look like? Is this so familiar? S of B minus S of A? How do we get the S function if we have velocity? S function is a position function. If we have velocity, we integrate antiderivative. Is the antiderivative going to take the limits? The higher limit, subtract the lower limit. So this is really S of t, yeah, S of t from B to A. So at the beginning, we were integrating A to B of a velocity function. What's the velocity function in terms of the S function? What's the velocity's, maybe I should say, relationship to the S function? Derivative, so S prime. So, I know the velocity function, all we have to do is integrate it from A to B, and it tells us our displacement. Okay, so let's find the displacement for the ant from 0 to 4. What does that mean we need, or actually no, excuse me, it's not 0 to 4, but 0 to 3. So what does that mean we need to do in order to find the ant displacement from 0 to 3? From 0 to 3. Okay, I'll let you do that. Make sure you have that dt, that's always important. Raise your hand when you think you have the ant displacement, and make sure you know what it means. And you should have a unit to know what it means. You know the velocity function? Yeah, that would be good. Yep. Try to understand what that means. What's the velocity function? Oh, you already started. Sorry, I didn't see that you started there. Mm-hmm. Okay, make sure you set up the interval and write out each step. What's t squared minus 16 plus 8 integrated with the antiderivative? Okay. And all of those have the limits from 0 to 3. So top minus bottom, plug in the 3 first. And, oh, you're right, 18. 3 cubed minus 3 times 3 squared plus 8 times 3. Subtract, plug it in 0. Well, everything is multiplying by 0, right? So it's 0 minus 0 plus 0, which is just 0. 3 cubed without a calculator, 27. Minus 3 times 9. I would recommend writing them out so you don't make some easy little mistake because you did it in your head. What? Oh, yes. 27 divided by 3 is 9. 3 times 9 is, oh, how come I'm being, oh yeah, sorry. I was thinking that was also 27, because it's 0. Okay, so 9, then let's subtraction and addition left to right. 9 minus 27, negative 18, plus 24, 6. What? 6 feet. So in a sentence, can you explain what this means? What? Yep. The ant moved a total of 6 feet from 0 to time equals 3. Good. Okay, now this next one, similar, it might have one piece that's a little curious. The position of the ant given by the function s of t at t equals 0. The ant's initial position is not 0. The ant's initial position is negative 5. Find the position of the ant when t equals 1 second. So we know we can find its position by integrating. But when it has an initial position that's on a 0, any ideas of what we'd have to do? Yeah. What's the initial position called? In terms of the function s. S of 0. And then we'll add integrating from 0 to 1 of the velocity functions, which tell us the position after 1 second. And S of 0 is information they tell you. The starting position is negative 5. Then we're going to add, integrating that quadratic again, t squared minus 6t plus 8 dt. To find its, make sure that looks like a 5, not an S. To find its position at time t equals 1. Okay. Good. So what are you all getting? 1/3. So set at -5. Now it's at 1/3. So S of 1 is 1/3. Yeah. So find the position of the ants at t equals 3 seconds. Now does it still have the original initial? So we still have that S of 0, which is at -5. So make sure you have to remember to adjust for that. And then we'd be iterating the velocity from what to what? 0 to 3. Yeah, we do know it's 6, so we don't have to do it again, which is 1. So its position is 1 feet. Okay, find the position of the ant at 2 seconds. That's the same thing, right? And 4 seconds. So we do both of those, and then at the bottom, draw a picture of the motion of the ant along the axis provided. at -5, right? That's an S of 0. S of 1, where is he? S of 2, 1 and 2/3. So it's still going in the same direction. What happens at S of 3? Goes backwards. S of 3 is 1. And S of 4? Goes back to 1/3. Okay, one last one together as a class is part D on the next page. Determine the total distance. How is total distance different than total area or total displacement? As far as it traveled, but in this case, we have going in the positives and the negatives. So how do you know the total distance traveled if there's positives and negatives? Absolute value. Yep, exactly. Okay. S of t over 4 seconds would be any range from 0 to 4 of the absolute value of the velocity. Okay, so we have 2 parts of the absolute value. We have a forward direction and a negative direction, right? From what time to what time is it going forward? 0 to 2, and then it changes going backwards from 2 to 4. So we're going to split this. So we have 2 sections, one on the left side without a calculator. We're going to split this. It's forward direction and 0 to 2. Just like we would put an absolute value function, we have the negative slope and the positive slope of our quadratic, t squared minus 16 plus 8. And all of that should be in brackets or parentheses dt. How do we make the second section be positive? Because the absolute value is positive distance. We minus it because when it's going backwards, it looks negative. So the minus negative, it will make it positive. From 2 to 4, t squared minus 6t plus 8 dt. Okay? I think you can do the rest, and then when you're done, go through and check with your calculator. But a warning, how do you make sure the calculator knows you're doing the absolute value? Okay, sure. You can do it in a shorter step. You know where the absolute value button is under the math tools, and then plug in velocity, comma x, comma 0 to 4. Okay. So first do it by hand, the analytical way, and then do it with the calculator, double check.